Okay, so now we're going to talk about logic. So logic that we're going to be talking about is premised on something called if-then statements. Now these are conditional statements that are conditional, there we go, might as well spell this right, statements. So if-then statement is a type of conditional statement such that is phrased if, and then something, comma, then something. It's kind of a cause and effect. If this happens, then this happens. So there's this condition, right? And then there's this cause, or I'm sorry, if this is a cause, then this would be the effect, okay? So this is the condition to the statement, and then this would be the effect of that cause, all right? Now, the hypothesis, aka the condition in an if-then statement, right, is the if part of the statement. So we could say if hypothesis, then, well, if you have a hypothesis, then the conclusion is the then part of the if-then statement.
No problem.
So that would mean if hypothesis, then conclusion. So if, for instance, I say if an angle is equal to 90 degrees, then it is a right angle. The if an angle, if an angle equals 90 degrees, then it is a right angle. Would be an example of an if-then statement, and the hypothesis would be that you have an angle that's 90 degrees, and the conclusion would be it's a right angle. Negation, or not. When we negate something, we make it the opposite. Now we're talking specifically about truth value, which we'll talk about in a second, but an example of negation is, so if I have this, if an angle is equal to 90 degrees, the negation of that would be if an angle is not equal to 90 degrees. And then the negation of that, the then part, which is it is a right angle, would be then it is not a right angle. Now often the inclusion of a not will get you there. So if I'm negating something, negate the hypothesis, then I'm just throwing in a not that changes it to absolutely the opposite of what it originally was. Symbolic form. In order to avoid writing out the hypothesis inclusion over and over again, we'll use a shorthand notation. P arrow Q. This is read as if P, then Q. So this is a conditional statement, and P is whatever the hypothesis is.
Yeah, that's a pretty big issue.
In this case, and then Q would be the conclusion. So in words, P could be an angle, so we could say P is this statement, right? And then Q is this statement. So P is an angle is not equal to 90 degrees, and then Q is the angle is not a right angle. Now, please bear in mind, it is context sensitive. So it is possible that you could have a statement that says Q implies P. This means if Q, then P. It's just a shorthand way of writing it, and the letters don't make a whole lot of difference. So R arrow S would be if R, then S. Now, another way this might be read, if I see P arrow Q, that's also read as P implies Q. You're going to see that sometimes too. It's the same as saying if P, then Q. Okay, truth value. So if I've got a statement, like let's say I have statement P, which is an angle is a right angle. On the face of it, that statement could be true or false, just like I could say if the statement P is, it is raining. That could be true or false. We really concern ourselves about truth value, that is, this is really whether a statement, and when I say statement, I
Hey,
mean
did you get yours?
an if-then statement, right, is true or
That's perfectly fine.
false. So if I have a statement P implies Q, so if P then Q, then maybe it is a true statement. So if this P happens, then Q does happen, and that's true, right? If it is raining, then I get wet. Okay, let's say it is true it's raining, then you get wet. Let's assume that that's true. We could say that the truth value of that would be T, which means true, right? Or it could be false for false. So, for false rather. Now, don't dwell on this too much, but overall what we're looking at is whether or not a statement, as a whole, so a conditional statement is true or false. Now the law of detachment says this. If, sorry, it does not say that. It says the in
Alright, so
a
Ryan, I got yours.
valid if then statement,
Hopefully you got it, and there's one more person that can tell, I think.
the
This is
conclusion
another question of what we're doing right now.
is always true if the hypothesis is true. So this is one way to check too if an if-then statement is valid. So if I have if
No,
a triangle
You don't have to draw, you don't have
has
to do, okay, so
two
let me just share
congruent
this screen. You don't have to do a full-on
sides,
experiment. So right now, what we're doing is we're kind of
then
scientific method
the
thing.
triangle is
But like it doesn't have to be a full-on
isosceles.
experiment, just tell me what,
So this is a valid if-then statement, and it's true that if a triangle has two
Okay.
sides, then the triangle is
So now
isosceles.
go on it.
So when can we conclude a triangle is isosceles? If it has
Would
two
you like a
congruent
doc? 'Cause
sides.
that's what I'm doing. If
So
people
we
want a
cannot
doc, I can
necessarily
listen to the doc
conclude
on
anything
the,
about something being isosceles if we don't know it has two congruent sides.
See,
So
like, see,
this
part of
eliminates the
doc here.
ambiguous case.
The doc won't copy,
Um,
see those like 84, this like
And more
10 here?
importantly, what it means
The
if
doc won't- the
if
doc
this
won't copy
happens,
the
then this
table correctly,
automatically happens.
because it's
So
the
if this
original
happens,
one's
if
it's a PDF, so like this is the actual table.
this
So if you're using the doc, I can
happens,
send you a doc away. You can use the doc and then
then
just look at the table on the PDF. That's fine. You want me to send you one?
this
No problem.
automatically
Hey, and whoever asked about what we were doing, that is what we're working on right
happens.
now. So
So if you have a valid if-then statement, you know P is true, then Q must be true. This leads us to this next one,
you don't need to tell me
which
what,
says if
you
we
need
have a
to tell me which
series
ones change and which
of
ones
if-then
stay the same.
statements
You need to tell me which
such
ones
that
But the how big the flowers are would be the dependent thing on that one.
So let's take a look at this. If R, then S, which then the then part
You just
becomes the
need to
if part,
determine if you think that
if S
something
then
that,
T, right? Which then the
that
then part of
shows
that
that-
becomes the if part, then U. So what does this mean? So means if
Is that specific to hang on, let me just
R
go ahead and
is
see
true,
this. I'll share the,
then what? Well, if R is true, then we automatically get S. That's the law of detachment, right? Which then, we now know we have S. What does that get us automatically? T.
here,
Well, we now know we have T, so what does that get us automatically? U.
we grab it,
Then U. So, from this,
So,
the
and
law of
that's the
syllogism
one
means that
where
we can
if you
take a
have
series of
the
if-then statements and draw a final conclusion. R implies U. So we'd say, therefore, R implies U. And this is a consequence of the law of syllogism. So the law of syllogism allows us to combine these set series of if-then statements into a single one. By the way, sometimes we'll use this 3 dots in a triangle formation. That means therefore also. So the 3 dots means therefore. Now one thing I will tell you, mathematicians are pretty lazy, which means they'll use symbols. whenever possible. Okay,
Exactly.
let's assume we
That's
start
bigger.
with
Yeah, and
a
you can't write a whole.
valid
sentence
if-then
without
statement. If
it.
two angles are congruent, then the two angles are the same measure, which is definitely true. There are three different ways we can modify this. Specifically, we can take the inverse, which is the negation of the original if-then statement, meaning we've negated the whole thing. Same order, add not. So we're going to adding a not. We should make a comma there.
Well,
Add
that's
not
that,
to
though. What
both,
do you do with the
meaning
other one?
P implies Q, so this is our original,
Yeah, the other
right?
thing
This is
is
our
in the-
original,
Right, one's in the sun, one's in, and that's
would
the problem.
become
You can't
not
have that
P
second
implies
variable.
not
That's
Q.
the really big issue.
By the way,
I mean, if you put
this
them both in the
symbol,
column,
it means
technically that's okay.
negation. I probably should have mentioned that earlier, but mentioning it now won't hurt. So this means negation or not. So then we read that as not P implies not
Yep.
Q.
Who was
In
that?
words, if two
That's a no
angles
problem.
are not congruent, as you can see we just added the not, then the two angles are not the same measure. The statements themselves have only been changed by the not, but they are still in the same order. Now, this leads us to the converse.
And the only issue
not the
with
shoe.
that, just to let everyone know.
All it
that
is
they
we
don't
switch
have
the
that
order of the
table
if-then
on it,
statement.
so
Now
it's
please bear in mind I'm
table on
referring
the-
back to the original if-then
P,
statement, meaning
It may be easier to write.
P implies Q, which is the original if-then statement,
So,
original, there we go, becomes Q implies P. In other words, the if part becomes the then and vice versa.
it's there.
Now, this means what? If two angles are congruent, then the two angles are the same measure. Switches to become if two angles are the same measure, then the two angles are congruent. So if we're looking at this being statement P, and this is statement Q, we've now switched them up. So now we have Q implies P. It's that simple.
So there you go, and the other
Now,
person
the
has to talk to you
contrapositive
about
combines
that.
the inverse and the
We'll be doing that.
converse.
I'm gonna be in the
So,
breakout room, but I'll be
The
doing
inverse is adding the not but keeping the order. The converse is switching the order. So if we put it all together, what do we get?
What's up,
Well,
Ainsley?
The P and Q switch places, and they both gain the not, that is the negation.
Oh, did you
so
want,
in
did you want it
words,
back? I can't post it.
if two
but
angles
why
are
is
not
it
the same
it won't
measure,
let me,
then
Rick,
the
do
two
you
angles are
wanna-
not
do you want it
congruent.
back?
So we can see that we've added the negation, remember that are
Well,
not,
it won't, yeah, I mean, you can write it on paper, but the problem with the doc is it doesn't show the table, but I have no
and
problem making it
we've
back. The
also
problem is once I
switched the
put
order,
it
so
on
the
there,
original if becomes the
it
then
won't
and
let
vice
me,
versa. Now, there's an interesting thing about the
it won't let me,
contrapositive. The truth value of the
make it so that you all
contrapositive
get a copy.
is
So,
always
I'll do one right now, no problem.
the same as the original statement. Now, just as an example, this is a pretty simplistic one, but if two angles are congruent, then the two angles have the same truth measure is a true statement. That is what, by definition, the two congruent means, right? So, and then if two angles are not the same measure, then the two angles are not congruent is also true. Now, just by looking at it, you can figure that out, but even if you did not know or did not feel like thinking about it too much, you can always assume that and because it's always true, that the contrapositive, when properly written, always has the same truth value. The same truth value as the original statement. And that concludes our intro to logic.